Hey team, today I'm going to be showing you how to use Carbide Create and OnShape to take a part that we've designed, set it up for cutting on the CNC router. So to do this, first we're going to make our part in OnShape. Our CNC router basically is a drill bit that can cut horizontally, so it's good for cutting out parts that are weird shapes that we can't quite do on the drill press and bandsaw, but something that we can use on the CNC router. So this is actually a part that we're going to be using on our robot this year called the Caraboom Pinata. It's kind of like a carabiner thing, and it releases the robot, so pinata, it's like a pin release. Anyways, so what we're going to be doing is getting this part ready for cutting out on the CNC router, and I'll show you the creating of the toolpaths and then exporting out that file. And then the next video will be using that file in Carbide Motion to actually run the CNC router and turn this into a physical metal part. So first off, make your part in OnShape. I'm not going to cover how to do that. There's some other tutorials that will show you how to do that. Specifically, the second OnShape tutorial that shows you how to make a robot cart should tell you everything you need to know to make a part in OnShape like this. That's custom. This is just a sketch and extrude, and then some fillets on the edges to make it round and pretty and stuff. Importantly here, our thickness of our part does match the thickness of our material. This is 1/8 inch aluminum plate, which is our standard thickness of plate. You'll hear it called 1/8 inch or 0.125 inch thickness aluminum. It's also a special type of aluminum that's designed for machining. It's called 6061 aluminum, 6061. And this part can be cut out using that material. So yep, first thing we did was design this part in OnShape. And what we're going to do is get the part from OnShape into a program called Carbide Create. So Carbide Create is created by Carbide. I hate that those words match up there. Carbide 3D is the company that makes the CNC router. It looks something like this. So here's the Shapeoko router. You can cut out a bunch of cool stuff with it. Looks like that. We've got a similar one. This is the 5. We have the Shapeoko Pro, which is based off the Shapeoko 4. But this website has software for Carbide Create and Carbide Motion. So Carbide Create is for creating the toolpath for your parts, and Carbide Motion is the software that actually runs the router itself live. So today we're just going to be playing with Carbide Create. So download this if you don't have it already. It's free software. Click the button, click download, and you can play along with this. It's also pre-installed on some of the computers in the laboratory as well. Cool. So first off, we got to get our part from OnShape into Carbide Create. So in Carbide Create, I'm just going to make a new file. This is eventually where we're going to end up. You can see the toolpath here. These green lines is what we're going to be cutting out, but I'm just going to go ahead and make a new file and discard all these changes. Carbide Create is basically a quick way to make toolpaths using the Shapeoko router. You can draw stuff from scratch if you just want circles, squares, and text. But more common than not, we're going to be importing specific files that we can then have Carbide Create use. So unfortunately, Carbide Create, as far as I know, does not just import a specific type of file like a drawing file or a step file like a 3D printer could. So what we're going to have to do is a little bit of magic to try and convert this into something two-dimensional that we can then cut out. So before we do all that, Carbide Create here, we're just going to set this up to work with our machine. This might already be set for you, but just hit the cog icon on the top left here for job setup. Width and height of the material doesn't have to match. It's just the white framing here. Stock thickness, we do want to match. 3175 is the same thickness, I believe, as our 1/8 inch material. If you change this to inches, we can do that here. Yep, it's 0125. We are going to zero to the top of the material, and this is important when we start going into Carbide Motion to actually cut it out. It means the machine's going to be zeroed to the top. I prefer to do it this way. It's just easier to zero the machine to this. And our toolpath 0 is always going to be lower left. That just tends to be where we start cutting things, but make sure you have these referenced here. So thickness of the material, 0125 is fine, lower left. We're also going to set the job material to aluminum. Our machine doesn't matter that much. You can do Shapeoko Pro. Or whatever. The job that it creates doesn't matter there. What does matter in Carbide Motion in the next video, you do need to say it's a Shapeoko Pro. And then units, again, either way is fine. And retract height 1/2 inch is fine as well. That's just for the tool, how high it goes up when it's done cutting the part. 1/2 inch is plenty of space for us here. Most importantly, I want to reiterate here, this thickness is what we're going to care about the most. 0125 needs to match the material you're cutting. Cool. With that set up, we've got our design space here to start working. Like I said, if you want, you can just start creating circles or squares or shapes, and you can kind of round and edit and transform. This is not as powerful as what you can do in OnShape. There's no constraints or dimensions or tolerances in here, so if you just want to freeform some text, you totally can, but because we really care about the size and dimensions of this part, we actually need to export it and import it somehow. So what you can do in Carbide Create is if you try and import something, you can do, let's see, oh, here it is, import, and it gives you some file options. So it'll take DXF, SVG, or existing Carbide Create file. What we're going to do is an SVG file for this example. There might be a cute way to do DXF. I don't know how to do it yet, but I'll show you how to do it with SVG. It gets us close enough to what we need to do. So SVG files, if you don't know, are just a type of vector image file. So SVGs are kind of like JPEGs or PNGs or other types of images. I would bet this little icon up here is an SVG. A lot of these buttons might be SVGs. This logo is probably an SVG file. It's just a type of image file. The important thing with SVGs is they don't get blurry, which means if you take a drawing that's straight on and we turn it into an SVG, this image like this, it can convert it into straight line and then curve and then straight line and curve and not really care about all the little like shaded and colored edges and stuff on it. So to do that, we're just going to literally take a screenshot of this part, bring it into Carbide Create, and then we're going to scale it to be the correct size. So to do that, we're going to change our view settings over on the right here and change it from shaded with edges to unshaded. That's going to make it really bland and boring in 2D, but that's perfect for us because all we care about are the dimensions here. We're going to open up the snipping tool or anything to take a screenshot of this and literally just take a screenshot of that part. Now this is going to want to save it as a JPEG or bitmap image. We want to convert it to an SVG, that's fine. So it automatically saved here when I took the screenshot. So now we're just going to use an online conversion tool. Adobe has a good one to go from PNG to SVG. So we're taking our bitmap images into a SVG image. We'll click on upload and see if we can find our image. I've done this a few times. I'm not sure which one's from today. Let's see, 224, that sounds right. We'll let it do its conversion process for us here. We'll give it just a second to make an SVG file. Perfect, and we'll download that. You can see I've done this a few times. This is now file 3. I'll make sure I get that right one. Great. In Carbide Create, we're just going to open file 3, which comes in as this giant image. So what it tried to do is convert pixels into SVG and then SVG into inches. This is something like, I don't know, 1,000 pixels. Maybe it turned like 1,000 millimeters or something crazy. So we just need to scale this down to be the right size. So if we go back in OnShape here, we're just going to do some quick measurements. I'm going to change measurements to inches because we've turned Carbide Create into inches. Millimeters would work fine. You just have to convert it if you want. We're going to click our 2 farthest edges on the part. That happens to be our left and right edges. And we can see our distance is 1.786, and I clicked left first, so it went negative, but that's fine, 1.786. So now, oops, that's OBS, that's the recording software. There we go. Now in Carbide Create, we're going to scale this thing to be 1.786 across. So we're going to hit this scale button for transform, and our width, yeah, it's currently 17 inches, so 1.786. And then if you just click the height, because scale factor is 1, it's just going to automatically convert it. We're going to hit apply, which shrinks it down to hopefully the right size, and then hit done. And we're just going to drag it to the very bottom left corner down here. You can zoom in a little bit with the scroll wheel to get it kind of measured up. So this is where the tool is going to start. So when we zero the CNC machine, it's going to start here, which means we're going to be cutting up and to the right of our part. The other thing that's good to check after you scale it, if you go back into scale, you can see width and height 1.786. And our height is 0.9839, so we can go back and make sure the height was correct. So if we click bottom and top, our height here is 984. 9839 is close enough to 98425, so we're going to call that a success. If you're off by 1,000th of an inch, I'm not too worried. Our CNC isn't even that accurate. Cool, so now we have basically the drawing of the part that we want in Carbide Create, so this matches what we have in OnShape. And now we're going to make a toolpath for it. So we're going to click the Toolpaths tab. And this is in Carbide Create, we're basically telling Carbide Create to plan out the path that the tool, basically our end mill, our cutting bit, is going to make to cut this shape out. So Carbide Create right now wants to know a couple different things. What tool are we using? It wants to know which side we're cutting on, how far are we cutting it, what type of cut are we going to do? Are we drilling stuff? Are we doing like a pretty carving, like a three-dimensional carving of it? So all kinds of crazy stuff. We're just going to be doing contour cuts. Contour is just a curvy line cut. So we're going to do that here. There's two different cuts we're going to end up doing. One of them is for these circles, and one of them is for this outer perimeter. I'm actually going to do the circles first because I think when we're cutting our actual part out, we'd rather drill these circles out and then cut this bit out of the material. Otherwise, if we cut this part out and went to drill the circles, because this would be removed from our stock, it might move around. So anyways, I'm just going to click the circles here. I'm going to hold Shift, I believe, to click all three. They're going to turn from purple or pink to orange here. And we're going to click the contour button. So once you're in here, you might get different options than this by default. We're just going to go top to bottom here. We need to select the tool that we'll be cutting with. So click Edit and then click Select Tool. Make sure at the top your material is set to aluminum. The first few bits that I broke, this was not set to aluminum, and I ran the CNC at wood speed on aluminum and it broke our bits. So make sure aluminum's dropped down here. Click Shapeoko Aluminum, End Mills, and select the bit you'll be using. You're probably going to use this 1/8 inch end mill, this 102 bit. This is the one we have like 10 of in the lab, and we've used it everything so far. This other one here is the zinc coated bit. So if you switch to that, you can, but if you look at these properties, they're actually the same. So it's going to work the same there. So click your 1/8 inch one, again, aluminum 1/8 inch, select. It's going to automatically fill out all these cutting parameters. These are called your feeds and speeds. You can look these up later. If you have custom bits, you can change these and get fancy and stuff, but the Shapeoko defaults have been working great for us so far. So we'll click OK, and that tells Shapeoko how to manage that bit. Start depth, we're going to start at the top of the material, 0 inches. Remember in these settings at the other page, we said we're zeroing to the top. And then for the depth of our cut, for this one, we're going to go all the way through. So use stock bottom, you can just click this button and it changes it. If you didn't want to go all the way through, you could change this number to what you want, or if you want to destroy the wood underneath the metal material, you can go deeper and it will let you do that, but stock bottom is usually what you want. Offset direction gets a little bit weird. So this is trying to say, you have this orange circle. Do you want the orange circle to be what is left over, or do you want the outside of the circle to be what's left over? So you can see orange is what our circle is, and blue is what it's recommending the tool is. So it's saying we should cut the outside of this circle. Our bit has some size, so this would be a 1/16 of an inch here, or an 1/8 inch for the whole size of the tool. And we would be cutting out a bunch of material here. Like if my cursor were the bit, it would follow the center of that, and you'd be left with the orange circle. Now that's not what we want. We want it to cut the orange circle out, almost like it's drilling a hole. So this offset direction, we're just going to play with it. Let's go outside right. There we go. And now it's going to do a little tiny circle on the inside to cut the inside part out, essentially drilling this hole out. These are M4 holes. Our bit is 1/8 of an inch, which is slightly smaller. It's about M3 sized bit. So it'll just do a little tiny circle here, but because our bit has thickness, the edge of the bit is actually going to cut all the way on the outside of this orange circle. Cool. There's no tabs for this one. I'll explain that after. And just give it the default name I've been playing. So this is on 4 already, but yours might be 1. You could name this if you want, like circles or holes or whatever. That's okay. We'll click OK. It's going to spin for a second and tell you it takes under 2 minutes to do that cut. Sounds great. So now we're going to do the cut for this outer piece. So we're going to select that path. It's going to turn to orange. We're going to click contour. You can change the bit again. I believe it keeps the default settings, but I'll go through it again. Aluminum, end mills, 102, select, OK. Yep, it's all the same as it was. Make sure you click use stock bottom so it cuts all the way through. If you forget to do this, I'll show you how to check that we did it correctly later. And then our offset direction here, we want to have this part left over when we're done. So it's recommending that the bit stay on the left side of the piece here, which is what we want. That way we're left with this orange piece as our remainder. I'll show you the other option. The other way is it can cut the inside and we'd be left with the outside. So this would be cool if we had like a big piece of metal and wanted to cut a weird shaped hole out of it, you'd select this option. And again, depending on the part, I know it says inside, which is actually the outside of our part. it doesn't know what the inside and outside are. It's just left and right. Cool. One other thing we'll do on this piece is we're actually going to put some tabs in. So if you picture cutting this piece out, by the time you get to the end, this whole piece would just be disconnected completely from the rest of the aluminum plate that we're cutting it out of. That can be a little dangerous because there's a high-speed spinning bit that will be cutting this out, and when this piece does break free, it's just going to bounce off of this spinning end mill bit and fly off and do something bad. So you can put something called tabs in. Tabs are basically little thin bridges that the machine will leave between the path you're cutting and the rest of the material, and you can usually bend these off by hand or take the Dremel to them if you're really desperate, but you kind of just like peel them off at the end when you're done. So we'll click Edit Tabs. The default tab width and height are pretty aggressive here. This is 1/2 inch wide and basically our whole material thickness. Remember, our material thickness is 125. So we're going to make this significantly smaller. Let's just say it's 1/10 of our material thickness. Sounds about right. So we'll go 0.125. That's going to leave us a little bit left over. And then the width of our tab, I don't know, 1/4 inch sounds fine. Even that might be pretty big. So maybe like 0.2 or something. And we'll see what this looks like in the preview. So we've selected our tab here. Depending on your version of Carbide Create, sometimes on this screen is where you click the tab. So it's saying place tabs, click on source vectors to place tabs. So we're going to put one right in the middle here, and then maybe at the bottom here. One on each side should be enough. Could also do left and right, that'd be fine as well. And click OK. If you're doing a different version of Carbide Create, newer versions, I believe you set tab size here. You click OK, and then you go back to your design view, and there might be a button down here for adding tabs when you're done. And you would click the tab button here and then click your tab spot and go back to Toolpath and it'll regenerate. I don't know why they moved it in different versions, but just be aware that tabs might be different. If it changes to a third way, just Google it, setting up tabs in Carbide Create, and you'll find a little thing that'll tell you. Cool, so we have our toolpath for these circles. We have our toolpath for our outer part as well. We've got some tabs to make sure that our piece stays in place. And to make sure we did it right, you can click Show Simulation. So this is really a good way to check and make sure we did everything correctly. Scroll to zoom, right click to pan, left click to rotate. Same as most applications, so you'll figure it out. And you can see that this actually looks pretty good. So we're going to start right at our end here. It doesn't quite know where we're starting. We're actually starting off to the side here, but that's okay. We're going to come over this red line first and do this circular cut all the way down. With 1/8 inch thick aluminum, there's usually 10-ish passes, so you should see about 10 green lines. We can count them real quick. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, maybe 13 lines here. You want to have lots of lines. If you do end up selecting wood as your material by accident, you'll see like 1 or 2 green lines, which means that it's just going to try and cut through the whole thing in one pass, which our machine cannot handle. The aluminum is too strong of a material to handle that. So make sure you have this like a giant stack of green lines, and then make sure the toolpath looks good. So it looks like we're gonna start here, cut out, boom, 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 and then come back here and machine out this perimeter because it's in that order. This looks good. We're also taking a look at our tabs. So here's the tabs it's planning on making. You can see, if I can get an angle here, the rotate is kind of weird because our part's not in the center. It's a super thin tab. That's like 1/10 of the material thickness, which looks about right. That's something that you can just kind of bend and break off by hand, which is what we want. You'll also see our drill bits tapered a little bit at the end, which is why we get that little tapered edge, but no one's going to notice that. And the thickness of this tab, or the width of this tab, looks pretty decent as well. So you'll see that part once we're done with it. And then there's a tab at the bottom. We could have put this in the middle. I think it's just more confusing. I like to keep it at the bottom. When we actually cut this out on a plate, you'll see our plate in the next video. There's already a bunch of pieces missing out of it. We'll just zero the machine to the next open spot. So don't worry about too much where it is on the plate. Just make sure that these toolpaths look good. Yeah, so that's pretty much it. Here's our final toolpath here. I'll go back to the part that we exported from OnShape. It looks pretty close to the right thing. Once you actually machine it out, it's going to look pretty darn close as well. This won't get you absolutely perfect stuff, but the desktop CNC machine is not super accurate to begin with. You know, it's plus or minus a couple thousandths of an inch, so it'll do good enough. From here, I guess I should say the final steps here. You'll probably want to save this. You can just save it as a Carbide Create C2D file, and then when we eventually open up Carbide Motion, you can just open up that same C2D file and it knows how to like translate it from this file into something that the CNC can use. I think that's everything. Here's your toolpaths. It should take about 6 minutes to do the cut, which sounds right. You can click hide simulation to see back where we're at. If you do make any changes to the design here, you will have to go back and redo your toolpaths. If you mess something up, you can always delete the toolpath and then add a new one by clicking the contour button again, selecting your path that you want, and all that kind of stuff. And you can play around with this and do stuff. If you want to get real creative, this will take SVGs as well, not just ones you generated. So you could go find an image of an SVG of a rubber duck or something and import that, and you could cut it on the machine as well. So not just stuff we've made, it'll take anything into it. All right, I'll hopefully see you in the next video where we're going to take this C2D file from Carbide Create, bring it into Carbide Motion. We'll have the webcam set up on the CNC router and actually cut this part out on the machine. Thanks for watching.